Here we are in the second video of three videos I believe. This is the third day of our similarity unit. We're dealing with proportionality ideas within triangles, within similar triangles. The last video we talked about the Triangle Proportionality Theorem, which dealt with a parallel line that ran through a triangle, and we said that those proportions, those A to E and E to B, proportional to A to F to F to C, right? This idea up here that we could apply. And so we're going to talk about the converse. And if you remember converse says, no, we're not going to write if P then Q. We're going to write if Q then P. And so the idea goes like this. Instead of saying if the lines are parallel, these two lines are parallel, then it cuts these proportionally, we're going to work backwards and say, listen, we can use that to check. We can say if the proportion holds, then they must be parallel. See what I mean by converse, right? We're going to use the idea, we're going to check and see if there's a ratio first. It's kind of like checking your answer first, right? We're going to check and see if the ratio holds, and if it does, that tells us that the lines are parallel, right? This is the if part now, and this is the then part. So it's just a little bit backwards. It's the taking the idea, and we're going to work backwards with it. Okay, so you can guess in these problems, we're going to be checking some proportions and making sure that things work, right? The question is now, are these sides of the two lines parallel? Is KL here parallel to MN here? Question mark? I don't know. I don't know if those two lines are parallel. So here's what I know, though. If they're parallel, that means that these two are the parallel lines. That's my base, right? Okay? And that means that this must cut these two sides proportionally. So that means then that 42 is to 21, 42 is to 21 as 30 is to 15. If that holds, if that ratio is the same on both sides, then they're parallel. Okay? 42 over 21 is a 2-to-1 ratio. 30 over 15 is a 2-to-1 ratio. You know what? It's 2-to-1 on both sides. If the sides are proportional, the answer is yes. KL is parallel to MN. How do I know that? Because they have the same ratio. If I would have gotten different values there, that's how I answer no. Now, we can take that and we can even go a step farther. We don't have to be dealing with triangles necessarily. You do understand, by the way, this is really a triangular shape that I'm working with, right? Let me get out the straight edge out of my drawer, okay? Then if I were to take and just continue these lines on up, you know that's part of a triangle, right? Okay, so it doesn't really matter whether we're dealing with triangles or if we're just dealing with parallel lines. You know, it's the same idea. If we have some lines set up and these lines intersect these two transversals, then they're going to divide it proportionally as long as we meet this requirement. That's probably the most important word, if they're parallel lines. Okay, I can say that A to C is to CE as BD is to DF, right? And so I can set up a statement that looks like this. Okay, so what if this is 5 and this is 10, this is 4 and this is X? What's X? Well, I could say then, if these lines are parallel, I could say 5 is to 10 as 4 is to X. That's a basic example. You could probably do that one in your head. X is going to end up being 8, right? Or you could cross multiply to solve. It's okay. But that's the idea. All right? One last slide, and then that'll be done with this video. So here's an example, right? An artist used perspective drawing to draw guidelines to help her sketch a row of parallel trees going off in the distance, right? She then checked her drawing by measuring the distances between the trees. Trees, not tress. What is the length of L to N? So on this picture, you probably have a hard time drawing. You might want to pause it. You don't need to draw the trees necessarily, but you might want to pause it and just draw this triangle here with A, B, C, D, K, L, M, N, right? Put those links in. When you're ready, you can unpause it. Here's the basic idea, though, okay? I want to find the length of L to N. Now, I notice that these lines, the trees are all vertically going straight upward, right? So they're parallel. Here are my parallel lines in each of these cases. It might be helpful, in other words, to go like this so I have my triangle with my base, all right? But this is going to cut everything proportionally. Well, here's what I know. If I'm finding the distance, now notice it's from L to N, right? That's this point to this point. So I'm skipping a tree in the process. That means I need to skip a tree in the process here too, right? So this is 1.4. Here's another 2.2. That's a grand total of 3.6, right? 3.6 centimeters from B to D. Well, here's what I know then. The 2.4 here is to the 3.6 here, as the 2.6 on this side is to the LN, we'll call that X, down here, right? Notice the main thing whenever you set this up, notice that I just have to make sure I'm using the corresponding parts. The 2.4 is from A to B, so I have to use K to L on the other side, 2.6. The 3.6 is from B to all the way to D, skip a tree, which allows me to go up from L, skip a tree, over to N on the other side. So now, a little cross multiplication. I haven't done this one yet, so I got to do it on my calculator. 3.6 times 2.6 is 9.36. That's equal to 2.4 times X. We'll divide out the 2.4, and I get X is equal to 3.9, and that's centimeters, right? 3.9 centimeters is the distance on the picture from L to N. So hopefully that makes sense. That's the second of 3 videos. I've got one more dealing with triangles and the angles inside.